We're here in Reveille Proving Grounds in Burnet, Texas. We're validating standard test methods for underwater vehicles. Reveille Proving Grounds is the only facility in the U.S. using NIST tests for all three phases: aerial drones, ground robots, and underwater ROVs. We're here with a roster of emergency responders from around the country. They help to generally develop the test methods and validate them with their use cases in mind. So you'll see us standing around this frac tank here. Frac tank is the clear water baseline test environment. No excuses. It's clear, it's still to start with, and we can all see the behaviors of the underwater ROV as it's trying to perform the various tasks. And the tasks include non-contact inspection in these omnidimensional C-frames. There's a grasp task. You see where they have to pull the floats to disengage. That's the equivalent of maybe grabbing a backpack off the bottom of the water and bringing it to shore. There's a hook task. Hook task can either involve the grasping device on the ROV, or it might be to hook a secondary pull line. Here on site, we have a deep water quarry, which is relatively clear. And we then transition the test methods to the dock in the quarry, so we start dealing with more operationally significant water. That means they can't see as far. Not being able to see as far means you need to start bringing other sensors into play, sonars, for example, to move around objects, to station keep. So the third body of water here at Reveille Proving Grounds is their pond. We embedded sonar targets in known locations at the bottom of the pond. These are our props. They are not operationally significant. They are just easy to replicate all over the world and easy to implement as a search task. So developing test methods and validating those test methods means you're exercising both the equipment and the test method at the same time. So we put the test methods in front of a wide variety of system capabilities. Those systems sometimes aren't performing particularly well in the test. That doesn't mean it isn't a good test, but the tests have to measure from relatively poor performance all the way through to excellent performance, maybe even beyond the state of the science. So our test methods capture all the performance and put them on the same measuring stick. And that's ultimately how you can compare system to system to system. But what we did here also with some of the responders that came is we used the frac tank and the first two tests, non-contact inspection and the soft grab test, as remote operator training and evaluation process. So we've done this with the drones in the air. It's very popular worldwide. Having 10-minute trials or 5-minute trials in a known environment that is replicated everywhere and can be performed every 6 months or so is a way to ensure the proficiency of the remote operators, which is a very perishable skill, and ultimately to potentially credential those operators as competent. That's happening in the drone space. It's probably going to happen in the underwater space, and having standard test methods as the underlying measurement science is the key to making it all happen.